Hey guys, we're now in Chapter 1, 2, Section B. If you realize, we have just skipped Chapter 1, 2, Section A. We didn't really skip it, but we covered Chapter 1A by playing the integer exchange. And on the integer exchange, you were given two colors of chips. One color you designated as positive. For this demonstration, my white chips are going to be positive. And for the other color, you designated as negative. So for this demonstration, my red are going to be negative, okay? Positive is white for us, and red is negative for today's lesson. Now, along with our chips, we're also going to be sharing the screen with you on this podcast. So be patient as we flip back and forth from what you see on my computer and what you see me, actually. Chapter 1-2b, page 40 in your textbook is adding integers. Two standards we are covering. Add, subtract, multiply, and divide integers, fractions, and terminating decimals, and perform exponential operations with rational basis and whole number exponents, including solving problems in everyday context. The second standard we're going to be covering in this section of the chapter is use and justify the rules for adding, subtracting, multiplying, dividing, and finding the absolute value of integers. This should sound familiar. These are things we have been practicing throughout this chapter so far. All right? So, going back to using our chips. Let's say that you are watching or playing football. On first down, you're at 0 yards. You haven't gained anything, you haven't moved up the field, nor have you lost anything and moved back on the field. But let's say when you have first down and you snap the ball, but the quarterback gets sacked. So because you're behind the line of scrimmage, you've now lost 2 yards. So that will be represented by -2, which is 2 red chips, okay? You're at second down. You snap the ball again, and you pass it behind you to your running back. But your running back gets tackled behind the line of scrimmage again, resulting in another 2-yard loss. Okay? So you've lost 2 yards on first down, you've lost 2 yards on second down. Altogether, you've lost 4 yards. See with our red chips. Let's show it using a number line. Our number line, as seen on the screen in front of you, says that we started at 0 on the line of scrimmage. The ball was snapped and we lost 2 yards because the quarterback was snapped. Or the quarterback, when the ball was snapped, the quarterback was sacked, not snapped. We hope the quarterback's not snapped. We want him to be safe. So we move backwards 2 yards. 1, 2. Now at second down, pass the ball behind us to the running back, and he is tackled, another 2 yards lost. So altogether we end up at -4. -2 plus -2 is -4. Okay? Now we know this because we are adding numbers with the same sign. These were both losses. They were both negatives. So on the number line, we ended up moving in the same direction. And because we moved in the same direction, we could have added the values 2 plus 2 and taken the sign of negative because both 2's were negative. Okay? Now let me have you think about this. Let's think about walking it out. If I walk 2 steps north and 3 steps north, where am I relative to my starting point? Well, north would be considered up, so we would call that positive. So I've taken 2 steps positive and 3 more steps positive. I'm in the same direction. So because I'm moving in the same direction, I have 2 plus 3, which are 5 steps north of my starting point. Now, look at the second example on the walk it out. If I walk 5 steps west and then 5 more steps west, where am I relative to my starting point? West is to the left, so this would be considered negative. -5 plus -5. Because I walked in the same direction, I add 5 plus 5, which is 10, and since west 5 is -5, and west 5 is also -5, both digits are negative, my answer is also negative. -5 plus -5 is -10. Look at the third example of walk it out. If I walk 3 steps south and then 4 steps south, where am I relative to my starting point? Both numbers are going the same direction. 3 plus 4 is 7. Now we have to decide, is south positive or is south negative? Well, south is down, so south would be negative. Negative 3 plus negative 4 is negative 7. In the final example, there's a little bit different situation. I walk 2 steps east, which would be considered positive, and then 0 steps east. Positive 2 plus 0 is positive 2. Okay? All right, now let me show you something different. In your textbook on page 40, which I have in front of me, I notice a science example, and I love science, so I am so excited about this example. It's something you will learn in chemistry as you continue on in high school, but it's something you will also learn in your 7th and 8th grade science classes. It talks about the atoms, and they are made of negative charges, which are called electrons, and positive charges, which are called protons. Now, there are also neutrons in the middle, which are neutral, just like the word suggests, neutrons. Remember, our neutrons are like our 0 pairs. We could have 1 positive and 1 negative, and they would cancel out, making a neutron, okay, or a 0 pair. So that's what a neutron is in an atom. It's 0. It has no charge whatsoever. It's not negative and it's not positive. It's simply neutral. It takes up space and it adds mass to the atom, but it does not change its electric charges. Now, they tell you that the helium atom shows a total of 2 electrons and 2 protons. So the question in front of you says, how can you represent an electron in a helium? Well, using our chips, since an electron has a negative charge and there are 2 of them, we would need 2 negative chips. Then it tells us to represent the protons. How many protons did we have? 2. Protons have what kind of charge? Positive. So there are 2 positive charge in the helium. 2 positive and 2 negative. 2 protons and 2 electrons. Number 3 tells you that each proton-electron pair has a value of 0 because, what did we say? A positive and a negative cancel each other out. 2 opposites, additive inverse, cancel each other out. So since these are now canceled, what is the charge on a helium? Is it positive or is it negative or is it neutral? Well, we have no more positive only or negative only chips. They've all been canceled out. So our helium atom is neutral. It has no charge whatsoever. It is a noble gas and does not like to attract to other atoms. Okay? So it's very special because it's all self-contained and it loves itself and it doesn't want to do anything else. It's just happy being by itself. So it doesn't like to combine with other atoms and make new elements and new combinations, okay? So looking at that example, let's now go back to our slideshow, and I want to show you our next slide. In our next slide, we have that idea of adding opposites that equal 0, the additive inverse, which creates 0 pairs. The positive and the negative cancel out, okay? If you have the same number of positives and the same number of negatives, which are what 2 opposites are, then they cancel out to be 0. So this is the idea of adding with different signs. If you have enough positives and enough negatives to cancel each other out, then you would end up with 0. But what happens if 2 numbers do not cancel each other out? Well, here's what happens. Let's go back to looking at our chips. Let's say, for instance, that you have to earn allowance, and like my daughter, she gets $5, okay? So $5 are her positives, all right? 5. But sometimes she doesn't follow the rules, and she ends up having a loss, okay? So we end up having to take some away from her. So if we say, you know what, you owe us $2 for your behavior. Well, she had 5 to start with, but she owes us 2 for her behavior. The 0 pairs, additive inverse, have to be canceled out. Okay? So we have more positives than we have negatives. Because of that, she still ends up with some allowance. She ends up with $3. Okay? So she had 5, okay, but she had a loss of 2. So 5 plus negative 2, cancel out what you can, and what's left over is positive 3. All right? Let's look at it using our number line. So let's go back to our screen that I just had. And we'll back up one slide. She originally, before she gets allowance, she starts at 0. She has nothing. She earns allowance, which is positive 5. Okay? Plus negative 2. Negative means I'm moving the opposite direction on the number line 2 spaces. 1, 2. What my solution, 5 plus negative 2 simplified, ends up being 3. Positive 3. Okay? So, looking at the next slide, let's read right here in the second portion, adding with different signs. On the number line, you move both directions, left and right, because you have positive and you have negative. So you are undoing some of the moves so they cancel each other out. So the shortcut, without using a number line or without using chips, is to subtract each number's absolute value. Now that requires us to review. Special note, absolute value means how many steps from 0. So going back to our example of the allowance and the loss of money. The absolute value of 5 is 5. The absolute value of negative 2 is 2. So we subtract those amounts. 5 take away 2 is 3. But how do I know if my answer should be positive or negative? You take the sign of the number with the greatest absolute value. So was the absolute value of 5 higher, or was the absolute value of negative 2 higher? In this case, absolute value of 5 is higher, and 5 was positive, so our answer is therefore positive. Okay? Now let's talk about walking it out. If I walk 4 steps north and 4 steps south, where am I relative to my starting point? Well, I started at 0, and I'm walking up 4 steps north. That's a positive 4. And I walk back 4 steps south. Where am I? Well, I canceled myself out, so I ended up right back where I started. Look at the second example. If I walk 5 steps west and then 5 steps east, where am I relative to my starting point? This is the same kind of problem. West is negative, negative 5, plus 5 steps east, positive 5, cancel each other out, and I'm back where I started at 0. Look at the third example of walk it out. If I walk 3 steps south and then 2 steps north, where am I relative to my starting point? Well, did I walk more south or did I walk more north? I walked more south, and south is negative, so my answer is automatically going to be negative. So how do I find how much negative? Well, I take the absolute value of 3 and 2. Negative 3 and positive 2. The absolute value of negative 3 is 3. The absolute value of 2 is 2. So 3 take away 2 is 1. I have 1 step left over that didn't cancel out. So my answer is negative 1, or 1 step south. If I walk 2 steps east, in example number 4, and then 4 steps west, where am I relative to my starting point? 2 steps east is like going right, so that's a positive 2. And 4 steps west is like going negative or to the left, so I have a negative 4. Positive 2 plus negative 4. Again, look at the absolute values. Which one am I further away from 0? I'm further away from 0 when I walk west, because the absolute value of negative 4 is 4. The absolute value of 2 is only 2. So my answer has to be negative. I am more west than I am east. The answer then, subtracting the 2 digits, 4 take away 2 is 2. So my answer is -2, or 2 steps to the west compared to where I was when I started. Okay? Now that I have gone over working on the number lines, finding out how to move using adding the same signs or adding different signs, I hope that you can use this in your homework examples. Thank you.